Hey Jack,
Hey Mark,
how are you this evening?
I'm very well. I'm very well. How are you?
Excellent, thanks. So we have big news out of the NVIDIA conference.
We do.
I think. So I guess today we're going to talk about the keynote speech, right?
That's right. Yeah, just go through some of the major topics that were talked about in the conference. I think it was a couple of hours. Um, Hopefully, it won't take us that long to go through the things that we're most excited by. But yeah, keen to go through it.
So I saw about 40 minutes of it, I think. So I didn't see it all, so I'm really interested in hearing more from you about what was revealed.
Amazing. Let's jump right in. So obviously, we're talking a lot about AI and big technological advancements. We've talked a lot about the impact on the world and these new big sectors that are going to emerge, and there's definitely going to be more of that in this video. But the first thing that I wanted to talk about was the next gen GPU architecture that was announced. Now, this is codenamed Blackwell. Now, some big numbers that have come out of this. So there's this new next gen GPU architecture has 92 billion transistors as part of it, and four petaflops of AI performance.
Yeah.
Now, I could have said 93 billion or 100 billion, and I wouldn't have known any difference. But that sounds impressive. And in terms of what that actually means and how do we actually gauge how impressive that is, I think it's easiest to compare it to the previous generation
Yeah,
of
yeah.
GPUs that came out. So the first thing to say is that the mid-range GPU in this generation is as performant as the previous generation flagship, and it's affordable. I think it's $550 or something for this GPU, which is as
Yeah.
performant as the previous flagship. That's nuts. That leap forward in what is available. And the new flagship that is part of this next gen GPU architecture is twice as good. It's twice as good as the previous
Mhm.
flagship model. And this is called the GeForce RTX 5090. Now, the reason I wanted to talk about this first is I think it's easy to trivialize quite how impressive that is. We talk about the advancement of technology. This is something that consumers use, right? This is what's in your gaming PCs, what's powering your games. And we've just had an announcement from NVIDIA that says we've just created a GPU which is twice as good. Twice as good. What's your thoughts on that, Mark?
Yes, I think I saw this bit like twice as good and a third of the price, I think. But I, I think this just goes to show like everything in the AI space is just going exponential, right?
Yeah.
Like the fact that they can just like double how good it is, like in such a short period of time, relatively. And whatever number of um, transistors you said was on there, like back in the old days, they're struggling putting hundreds of them on.
Yeah.
Yeah. And now
Yeah.
it's like trillions. Like
Yeah.
I mean, if that's not like some kind of exponential curve, I just don't know what it is. Like, that's mad.
Yeah. And it's really cool. I mean, like I say, the reason I wanted to talk about it first is because it's, this is existing technology, right? Like it's not anything new necessarily. It's just powering the same old computer that you have under your desk. But it's so easy to forget that because we've got all this new technology coming in, we've got AI agents, autonomous vehicles, you know, all this wicked stuff. And yeah, of course it is wicked, but the stuff that we've already got, the efficiencies, the improvements that they're able to make in them is astounding. And that alone from NVIDIA would have been an impressive update, in my opinion.
Did they say like anything about like what that means in the real world, in real world terms, like twice as good?
I mean, I'm certainly not an expert in this space, but I mean, I think it's twice as powerful in terms of its processing, in terms of how much it can produce for you, the quality of graphics, operations per second, all of those kinds of metrics. I assume it's that's twice as good.
Hmm.
Um, but I guess it means everyone will be gaming in as HD as you like.
Yeah, yeah. Cool. So, what was the next bit of news that they mentioned?
Next bit of news I want to talk about was data centers. So this is something which is very prevalent in this in this revolution. These are the things which allow us to call OpenAI or allow us to call, whatever LLM that we're using. These things are all powered by data centers. And along, with all of these improvements and advancements in technology, there also has to be improvements and advancements in the infrastructure that sits behind them. And namely, these are predominantly data centers. Now, the CEO of NVIDIA talked through the 3 scaling laws of AI, and what that means is that to scale a LLM or an AI model to be better, there are 3 things that we've got to consider. There's the pre-training scaling law, so that's bigger data sets, bigger models, more compute. There's the post-training scaling as well, which is more reinforcement learning, and that can be done with either humans or nowadays AI, and time scaling. So this is effectively the scaling that's required to allow the system to reason or to explore different scenarios before it provides you with an answer. So scaling up the performance of these models isn't a trivial thing. It's there's these three prongs that you have to consider. And what NVIDIA have released is that they have got a plan around this. They've got 45 factories building these things across the world. And what's so impressive is that this new generation of GPUs, which power these data centers, are 4 times more performant per watt. So in terms of their energy consumption, they're 4 times more efficient. And in terms of how does that translate into cost, along with the other things, they're 3 times more performant per dollar than the previous generation. I mean, that is insane.
that is yeah. I mean, no wonder that things are moving fast. And it's just with the number of, we were speaking in the last episode about the XAI data center, and like the number of like processors they've got there.
Yeah.
And if they're just like 100,000, right? We said, and 50,000 new ones they're putting in. Is it any wonder like these AI models like getting better? It's just really interesting. I think. I mean, I haven't like looked in any detail because like I'm fully aware of like the pre-training, the reasoning, and then the post-training, and because of like the amount of data that's been already captured, like captured all of the data that's available to be captured, like how do we improve things next? And it's like I did read an article about reasoning is like the next big, where we can make the next big advancement. Like we've got obviously we're still creating content, we're creating AI content now to feed the beast, but it's I don't know. I don't know where it ends. Like by the end of 2025, it's going to be. I think we're going to be in a different place, different world where we can't even understand now, and that's only 12 months away.
Yeah, 100%. And I think hats off to NVIDIA for being such an important enabler to this transition. Right, without this advancement in this technology, there's just no way that we can improve. Because maybe one of these tech companies develops a more advanced model, but you wouldn't be able to use it because you wouldn't be able to use it widely, at least, because there would be no compute to run it. It wouldn't be cheaper. It's with each iteration of, take OpenAI, for example, GPT-4 is now cheaper than what GPT-3.5 was. I mean, how can that make sense? A more performant model for less money. And it's because of this technology. That's a massive enabler of that. The energy consumption, the amount of compute that's required to do these operations is going down. And as I say, it's a big part, and these data centers are a big part of that.
It's going to get like that, right? Because it's like computers used to fill rooms and they were really expensive, and now like a phone that fits in your pocket is more powerful than a computer ever was. Like, so you imagine where AI devices and stuff will go in the future. You have something tiny, maybe around your neck or on your finger or in your brain. In your ear, like that's tiny, but like incredibly powerful.
Yeah, you can believe it. You can believe it. It's really, really impressive. And it leads me on to the next bit of news, which is that traditionally, AI has always been run on Linux systems. Don't ask me why, but Linux systems have been the ones that the performance has been available on. Now, what NVIDIA announced was that they're going to focus on making the Windows platform a first-class system, first-class AI platform to use for running these AI models. Now, why is that important? Well, we talked about data centers and the need for compute and the advancement, but right now across the world, I don't know what the number is, but I imagine it's very, very high, the number of Windows machines that are sat just being used for whatever traditional compute is used for. But what NVIDIA are going to do is they're going to unlock all of that power, all of that processing across the world. Literally millions of Windows machines across the world can now suddenly be first class at running these AI agents and these AI models. And that is, I mean, I don't know the technology that sits behind that, but that sounds incredibly impressive.
So hang on, am I getting this right? So they are saying if you run something on your machine, your Windows machine, then they're going to use your processing power to run compute? Or
Yes, I think so. I think this is less about like the commercial. If I call the OpenAI API, for example, it's not going to be powering that. It's more for powering local models that you host locally. And this is a really interesting part of development because a lot of people are skeptical or they have their own requirements as to why they don't want to be sending their data across the world for these big corporations to process. And understandably, right, people are apprehensive about that. And so what they need to do is they need to run these things locally in-house in infrastructure that they host. And right now there are options for that. You can purchase protected cloud compute, or you can run them literally in your office, in your bedroom, on a what up until now you would choose a Linux machine to do that. But what this announcement means is that suddenly you don't have to have a Linux machine, you can have a Windows machine. And so all of that compute power, whatever it aggregates to across the world, is now suddenly there and available for people to use, or at least it will be.
Okay, that's not quite what I thought it was. I was thinking it was something along the line. So I remember I don't even know if this is still going to happen, but a while ago, I don't know, a year or two ago, I heard something about Tesla cars, they're computers, right? And I'm sure I heard something about a scenario where you'll be able to rent your computing power back to Tesla or whatever.
No
So like if they wanted to run some stuff, you've got this computer sitting in your car, like they can just go and run something. Okay, those computers are not particularly powerful, but when you've got a collection, a load of them, and you're just running some operations on each one or whatever. Now I can't even. I'm sure I'm not making that up, and it wasn't a dream. But there was something around those lines. It was similar. It was similar around the same sort of time. They were saying, well, your car is also battery storage. If the utility companies want to harness some of the power from your battery, you could sell it back to them at a cost, and they can suck the power back out of your car because it's actually just storage, and then you can charge it again when they're a cheaper price when they don't need it, but you charge them for that.
I love that concept.
That was all kind of happening around the same time.
Yeah.
And like that stuff just sitting there.
In all honesty, I don't know, Mark. I imagine that there's definitely going to be a concept of that utilizing compute. I mean, certainly when I talk about it from the perspective as an individual, right, as a consumer. But there must be companies all over the world with access to, or they have their own significant compute within whatever systems they have, and being able to rent that back to these corporations or whoever will pay for it is certainly seems feasible if it's not already happening. Whether that would ever trickle down to the consumer level, like could I rent out the compute in my computer? Don't know, maybe. But what this Windows announcement allows us to do is tap into all of those systems from an AI perspective, so you can run all these AI models using that compute, I guess. And that's awesome, right? That's really, really, really cool.
Yeah, cool. Also reminds me of a long, I'm talking like a decade or two ago now, but you also used to be able to run a screensaver. It probably still exists on your machine, that effectively was looking for life communication from other planets. So like, we're listening to the universe like all the time to hear for different noises to see if we're being communicated to, but there's just too much data for like NASA or whoever it was, right? I think might have been CERN, maybe not CERN, but someone I can't. Yeah, I have to look it up, but someone can probably can say in the comments. But basically, you're renting up when the screensaver came on, it was started to like process some of the patterns and stuff from what was happening. I think they've done that with like maybe some cancer and some science stuff as well before in the past. But anyway, it's still another idea of like, we're going to use your processing power. I mean, you're doing it for free just because you want to help, right? In that case, but but yeah, that's kind of like the start of that. That's something wrong with that as well. Using just third-party processing power because you don't have enough yourself.
So how are you saying? So how does that work? NASA or whoever it was were sending whatever unstructured.
You run a little application on your machine. Yeah, you run a little application on your machine. So yeah, you'd be trying to solve puzzles. It's a bit like Bitcoin and mining, right? Like they're trying to solve a puzzle to unlock a new block. And people were doing that for free, and people were paying money to mine Bitcoin in the old days because it wasn't worth anything, like at the beginning. So again, it's like another example of that kind of stuff.
So these concepts have been around for a while. We're just applying them to this newer technology.
Yeah.
And NVIDIA are the ones that are unlocking it, which is paving the way. Right. The next thing I want to talk about now, this really is awesome, and this is away from the sort of consumer. Well, it does impact the consumer, of course, but it's the bigger topics, and it's into sort of robotics, right? So NVIDIA announced this thing called NVIDIA Cosmos. I'm not sure how you pronounce it. So you can understand right now LLMs are basically, they're all operating using tokens, and these tokens are text-based. In order to go from, models that are just AI in your computer into robots, we kind of need to evolve what those tokens are. They're not just text-based tokens anymore. So, example might be pick up this box, and I think they're calling them action-based tokens. So, they represent physical actions in real life, and that's what's going to be needed to sort of make robotics work. So what NVIDIA Cosmos is, what they've done is they've developed a model specifically for physical dynamics, so specifically for those kinds of tokens, and it's been trained on 20 million hours of video. 20 million hours of video, which is a staggering amount of content. I think even if you watch videos your whole life, I don't know what the numbers are, but you wouldn't get close to 20 million. It's crazy. Now, a couple of things to say. This has been open sourced, so this is available. And what they've linked it to is something called Omniverse. So again, this is something else that NVIDIA have got. And what this is effectively a simulation platform. So when you combine this NVIDIA Cosmos with this Omniverse simulation platform, what you've effectively got is an infinite realistic training ground. So with the model Cosmos that they trained on the 20 million hours of video and this simulation platform, you can confidently create literally any physical scenario that you can dream of, literally anything. And this is where you can start to think about. So there's obviously the robotics realm, but also into the autonomous vehicle realm. So this technology is the potential it has is staggering.
So what can I do with this tech as an example?
So let's say that I suppose let's take a robot, right? It will have seen how to pick up a box. It will have seen how to jump. It will have seen how to navigate a ramp, whatever it might be, because it has seen this on the video content, the 20 million hours of video. And that probably gets you to a very, very sophisticated point in terms of what the robots are able to do. Yeah. But you pair it with the simulation platform, and suddenly if there's any situation where you're not sure, or there's parameters that you've not seen, like, and I'm really just thinking out loud here, right? But let's say that you've never seen a video of a robot jumping off the roof of a building, and what happens there. What's the safest way to do that? Well, in this simulation platform, you can model that. You can model it 1,000,000 times, and you can see in which scenarios does it, does the robot break, and which ones does it not break. What about if you've never seen the specific scenario of and there's a natural disaster? What to happen if there's a hurricane or a flood or anything? I mean, there will be many scenarios that haven't been seen as part of this 20 million hours of content, right? But the simulation platform allows you to, or allows these models to work out what if. It's being able to answer the what if to almost any physical situation that you can think of.
No, I did see some of that actually. That part now I think about it. Yeah, so it's just modeling the real world. So literally, so you can simulate. I mean, it's scary. Like, this is like, if you don't already think you're in a simulation, this is literally simulating the real world. So like a high degree of accuracy.
Yeah, they can confidently do it. I mean, it's just the applications are endless, and the robotics industry is interesting, right? But the one that's a little bit easier to maybe wrap your head around is the autonomous driving. And you just take that scenario and you can model any situation. You think about some kind of situation where an accident might arise. Within this software, you can basically simulate every possible outcome. Literally every possible outcome. It's like, I mean, it literally sounds like straight out of a movie. Simulate every possible outcome and go for the one that's the most effective. I mean, that's the kind of thing that we're talking about. So from a safety perspective within autonomous vehicles, that's going to be a massive facilitator of unlocking that.
Yeah. Nice.
So that drives me on to the autonomous vehicles, right? So the chief exec of NVIDIA made a big claim that this is going to be a multi-trillion-dollar industry, and I don't think that anyone necessarily disagrees with him. But it's massive. It's going to be huge. Now, the statistics of the performance in this space are crazy. So the chips that sit behind this, the technology that sits behind the processing within this industry, are the numbers that are coming out 20 times more performant for processing sensor data. So data that's coming from cameras and whatever else autonomous cars are using. They can process that data 20 times more quickly with the technology that NVIDIA have announced. What does that mean? It means perception and planning capabilities are improving significantly. And so you chuck that into the Omniverse technology that we talked about before, and Cosmos. I think it's called OmniMap in specifically for autonomous driving. And what you can do is you can reconstruct real roads, cities, all in real time, right? All from what these sensors are providing. So you can reconstruct every city in any weather condition, any traffic situation, no matter how busy it is. Maybe there's a special event on. You can literally simulate all of these things, like real live situations. So you go from thousands of real world data miles that you can train these vehicles on into literally billions of synthetic miles, literally billions. Again, so it's kind of just that application into the autonomous driving industry. But the technology that NVIDIA are announcing and talking about is the facilitator for this. It is what unlocks the safety statistics that we've talked about in the past, Mark. Like, it's incredible. It really is.
I wonder how that affects kind of Tesla's lead, if you like, in the fact that they've, we talked about it in the last video, the Tesla video. So they have a massive advantage because they've got millions of cars on the road and have had for a number of years, which no other company is doing for a long time, with cameras in them. And they're tracking real life situations. And that's given them a huge advantage in terms of their AI for their autonomous vehicles, because their AI is seeing millions and millions and millions of hours of footage of real life situations over and over again, and they'll be able to learn from that. If we're now saying NVIDIA's got a synthetic way of doing that, does that mean that other autonomous vehicle companies, that gives them a chance to catch up?
It's a great question. I don't obviously into the outs of how these companies are operating, but as I understand it, I think NVIDIA would probably sell this technology to whoever will buy it, right? And if Tesla Tesla is one of those players, and I'm sure there are other players that are interested and using it. But I think the key to what you've said is about Tesla's real world data. You know, there's no real, you know, certainly from my perspective, you know, how do you validate that a simulation that you're putting into this technology? So you've got this great technology and you've got this model that can predict what would happen given these parameters, right? How do you verify that that's truly what would have happened? How do you know? And you don't, right? It's a simulation. That's the whole point. And the thing about Tesla is that they've got so much real world data that they are probably able to iterate to a better point of accuracy, or they're able to feed in more training data, I guess. Or, you know, in terms of training models, volume of data is always a massive part of that. So if you've got training data and validation data, Tesla are the ones that have got massive monopoly in that space, and that's the impact.
Yeah. That synthetic data probably isn't going to be as good, you know, completely, because it's just not real world. But I'm sure it's going to get better. It will get better and better. But yeah, like we were saying about the chart, you know, how many times it's seen an accident and avoided an accident, or now spots way ahead of time when there's a risk.
Yeah.
I guess simulate that. I mean, but I don't know. I haven't looked at these simulations. Like, I'm guessing if they're simulating real world to a high degree of accuracy, they can simulate cars and varying speeds. And I mean, I guess, you know, imagine. I'm imagining actually they're just simulating New York, an actual city with the same number of volume of cars at different times of the day, and probably simulating a like similar crash rate. If they're simulating it accurately enough, right, then there's going to be cars that are crashing or whatever. So I guess they could, you know, I don't know if they're simulating it to that level. I assume so. Like, if it's going to be trying to simulate real world, I don't know if it's real world physics. I don't know if you know the answer to it. Is it just real world physics, or is it real world human behavior as well that they're kind of simulating?
Yeah, great question. Model. Great question. I think that is potentially where these two things overlap, right? So you've got the Omniverse or the OmniMap, which is the technology which does the simulation, and then you've got Cosmos, which is the model which has been trained on the 20 million hours of video. Now, as I understand it, and you know, I'm again certainly not an expert in this space, don't know the answers to all these questions, but I think the simulation platform is what can accurately simulate physics, the physical side, and it's the Cosmos which is trying to, I guess, anticipate. It would be able to anticipate human behavior and the kinds of things that you might see in the real world. So it's that model which is able to say, oh, what happens if a animal runs out in front of the car, or someone runs a red light, or whatever it might be in that situation, and it's then able to whatever reconstruct that exact scenario in the simulation platform, and then do the what ifs times however many scenarios it wants to run. And again, that's just my sort of how I think it works. I have no idea, honestly, no idea.
Yeah. Cool. So now we're running simulations inside simulations.
Yeah,
if we are in a simulation,
it's quite terrifying. It really is. It really is. I think what's interesting as well is that the point you made about human behavior, right? Like sometimes, and I don't know this, right? When you're simulating a certain situation in the real world, there's obviously these models are running different scenarios. There's algorithms which are defining, okay, therefore, if you take an autonomous car, therefore I'm going to steer the vehicle in this direction and brake this much, or whatever it is that it's going to do to react to whatever it's seeing. But because Tesla is also able to collect data on how humans are responding to those situations, I guess there's an interesting question in there of whether or not there's ever any scenarios where the behavior is unexpected because it's being done by a human. So the reaction is not necessarily what the computer would have calculated to do, but yet it has resulted in a better outcome. So that, you know, maybe the maybe the computer has calculated a 70% chance of survival based on, you know, crashing into this thing instead of that thing, but actually in that situation the human was able to do something completely wacky and, you know, survive it without any issues. I don't know, it's an interesting thought, you know, that's just come into my head, but
Yeah.
I'm curious as to how that's playing into it.
Yeah. Cool. So what was anything else from the conference?
Final bit of news that I want to talk about was something called Project Digits. So this is your very own personal supercomputer, and all for the lovely affordable price of $3,000. And I said that slightly ironically. $3,000 is obviously a lot of money, but for a supercomputer, that is like cheap. It is very, very cheap. Now, Project Digits, why has that come about? Why is it a thing? So there is a demand for local performance systems. We talked before about the requirement for some people to run models locally, you know, whether that be because they're skeptical or because whatever their use cases demands that data isn't processed outside of closed systems. That in itself, you know, poses a requirement for capability, like real capability within local computers. And that's where Project Digits came from. And what have they done? Well, they've made this AI supercomputer, and you can put it on your desk. You can literally just stick it on your desk, and it performs. You can either plug into it, or you can, you know, treat it like a cloud-based platform where you connect to it. So, you know, this is a real revolution in terms of what you can do in a closed system, in a system away from the internet. And what's also impressive is that it's scalable. So you can buy one of these machines for $3,000, and you've got your supercomputer. And you can buy another one, connect it, and suddenly you've got twice the amount of power. You've got twice the amount of compute. So this is a really, really interesting development from NVIDIA. I think the timescales are that these things are likely to become available in May of this year. But yeah, what do you think, Mark?
Yeah, so I did see a little bit of this. So you can like literally connect them together with a cable, right? And then you know, they double up the power. So it's not like you've got two of equal power. They become one bigger supercomputer at that point, which you can run bigger models on. So yeah, I think that's amazing. Wait, I don't know if you can clarify something as well. I know you said you can run also if you want to. You can have them effectively as like servers, I guess, that sit and run these models, or you can run them as desktop as well. You said you can run Linux desktop, but there was also mention of like Apple and Windows, but I didn't quite catch. Can you run those operating systems on there as well?
Honest answer, I'm not sure. I'm not sure.
Yeah, I feel they must do, because like, what else were they going to talk about? What else were they talking about? But he didn't make it because it was separated some way. But anyway, forget that then. We'll pick that up some other time. But in terms of having a supercomputer, whatever you like, I don't know what the definition of a supercomputer is, and like whether they just decided they're going to call it that. But it's significantly more powerful than anything else. I don't know. Have you got any like numbers on that? Like, how much more powerful is it than your average desktop or your MacBook? Or, you know, I have no idea.
No, I'm not actually sure. I'm not sure how they compare to sort of domestic level computers. But it's clearly quite a milestone in this sector, being able to brand it a supercomputer at your desk. And I'm sure the capability that those unlock, you know, the power, the size, and the capability of the models that you'll be able to run has taken a massive leap forward. We'll have to have a look at what,
because the size of them are like a MacBook Mini, right? They're like, or even smaller. They looked even smaller than that. It looked really tiny. So it is incredible in that way. And thinking about it, you know, in terms of like use cases and stuff. Now, if you're an agency or a SaaS company or whatever working with businesses, it suddenly lowers that opportunity of having, you know, your own, like you say, closed network, super computer. Like, if people are sensitive about their data and they don't want it to go into OpenAI, they don't want it to go into Anthropic or Google or Microsoft or whatever, you can literally go, okay, well, I'm just going to create this. I'm going to put this tiny computer in my office. That's going to be running running all the LLMs for my customers, or whatever, or you'll probably run one or two LLMs, I guess, depending on what business you're in, and rather than going to the open internet, your customers are calling those, and data's all closed within that space. And that suddenly makes it very affordable for small businesses to be able to do that, right, for their customers.
Yeah, exactly right. And we talked about the concerns from a data perspective, but also I think a lot of people are nervous about that's another point of failure, isn't it? If you're relying on a big corporation, if your entire infrastructure for your business or the services you offer rely on being able to call OpenAI, right? If that's the core part of your offering, and suddenly there's two perspectives to look at it, right? One, they massively hike up the cost of those calls. Most people have got some kind of pay as you consume model. So cost or availability, right? Like what happens if the data centers aren't keeping up and suddenly demand does outstrip the ability to supply? Well, you don't have to worry about those risks because you've got your own, your AI model is in your office. You don't have to worry about any of those things. And certainly my experience that is something that companies do talk about as concerns when they're integrating this technology into their operations. And as that happens more and more, and companies, I don't know, maybe they go from 5% being powered by LLMs to 50% powered by LLMs and AI agents, that risk becomes greater and greater. An outage at the OpenAI servers, that's not like a mild annoyance. It's suddenly fundamentally gonna cause problems for multiple businesses globally. So these these supercomputers, that NVIDIA have announced, allow people to get around that and remove that risk, which I think is really, really impressive.
Yeah, I wonder how much that's going to potentially. I mean, I don't think we have to feel sorry for the major corporations because they're going the tech, companies. They're going to be okay. Like they've got so much business coming their way over the next 5, 10, 15 years with AI and all of that compute. And they're at the forefront. Those big, huge tech companies are going to be okay. But I'm just wondering, like, they kind of had a monopoly on compute, right? Because your average person could not go and spin something up which is as capable as a data centers that these massive corporations have. Now, if I want to start a company and I'm just thinking about the data that they're not going to have their hands on, like, if I started something, I had to use AWS, I had to use, Google Cloud. I have to use their messaging services, which they get all the data for. Suddenly I can just, I know I could start, and I wouldn't be surprised if there was I mean, I know there's, I know people that just don't like using social media, instant messenger, WhatsApp, things like that, because they don't want third parties, their messaging going via third parties, right?
Yeah.
So 100%. A selling point for a company is, I'm going to start WhatsApp, but it's going to be, I mean, I suppose you're just another company at the end of the day.
Yeah, at that point, yeah.
I mean, you're not a major corporation, I suppose, but yeah, I don't know. There's probably is use cases, maybe not something like that, where suddenly all that power comes out of the hands of those major tech companies, and it's going to be more siloed and smaller networks of very powerful computers.
Yeah, 100%, and that might become more and more prevalent, right? As right now, there's 5 or 6 different key players that are offering the most capable LLMs right now, but that might change, particularly because all this software is open source, right? Like people can jump on board, and if the blocker, as you say before, was compute, suddenly there's a solution to that now, and people are able to train their own versions of these models. So it's also going to allow for flexibility because you're not suddenly having to fire off to whatever models you're using. You can just run them all yourself on your one supercomputer. But it will be interesting to see. I mean, one of the great advantages of using corporations like that who have so much scale is that you're able to scale up and down your operations based on your demands. Whereas if you're suddenly going to remove that and try and do it all in-house, you have to have the capacity for your peak demand, right? Which is like, it's always going to be more efficient to scale in those situations. So it'd be interesting to see how this does affect demand in time.
And they still have all the tools, I guess. Like if you want to use Gmail, Google Drive, whatever, you're not going to be, just because you have a computer on your desk doesn't mean you suddenly run that. You literally can't, because it's going to be closed off from that. But in terms of just pure raw power and being able to do stuff that you couldn't do before, it's interesting.
Right, that's the end of my news spiel from the NVIDIA conf. Anything to add, Mark?
I'm just astounded, like how every week there's something else which kind of makes my head go pop. And it's unreal. It's unreal. And I feel like we talk about this, people just don't know what's coming and what's going to be possible. It's a revolution. It really is. And we're going to have a lot to talk about over 2025 because often you're not even seeing it coming. It's so fast. Like the stuff that Elon was talking about in the last message, and even NVIDIA. Why hasn't this stuff been, like some of this stuff, been leaked or even talking about? It's just one thing after another. They almost can't get it out and publicize it in time because it's just, there's another new thing and then another new thing. It's just like ongoing. So,
and I couldn't agree more with that.
In fact, it's getting exponential. Man, I'm scared. I don't know where it's going, but I'm going to enjoy the ride while we get there. All right. Well, thanks for covering that, Jack, and thanks for listening, everybody. Check out our Skool if you haven't already. The URL is on the screen. If you're listening on the podcast, it's skool.com, skool.com/AI-automations. It's not all about automations. That's just the URL, but check it out if you haven't already.
Brilliant.
Okay.
Thanks, everyone.
Thanks for listening, everyone. Bye-bye.
Bye.